So graphs are pretty and they tell us a nice story about what's going on in the data, but it's not enough. We need to actually run some summary analysis of the data, particularly descriptive type analysis of the data to make sure that we are making decisions that are proper about the data before we run an analysis. Those decisions are usually considered to be checking for assumptions. So there are several assumptions in statistics, and for the most part, most analyses require that data be normally distributed. And when data is not normally distributed, some issues may emerge. So how do we check for normality? Um, we've already seen that with our graphs, right? With a histogram, with a box plot, and we also saw scatter plots and examining relationships, not necessarily looking for normality, but how can we explore data numerically? Well, we do have exam anxiety activated here, and we're going to go simply to statistics and click on summaries, and we're going to say we want numerical summaries for the variables that are actually continuous. You can't do this necessarily with categorical data. For categorical data, at best, you can talk about frequencies, how often this is occurring, but not necessarily in terms of skewness, kurtosis. You may not be able to talk about means and standard deviations at all with categorical variables. So let's click on anxiety, and you might be able to click on code, not code, we don't want code, on exam and revise, and we want to click on statistics. And in statistics, we're going to click on the statistics that we want to see. These are descriptive statistics. So we have mean that is already clicked by default. Standard deviation is clicked by default. The interquartile range, which is what we saw with the box plot, is clicked by default. How about clicking on skewness and kurtosis to see if your data is normally distributed? And this is not the final test, but at least it helps us in making a decision. Let's go ahead and click on OK here. And we see that the script indicates that this is exactly what we did. We got numerical summary on exam anxiety, I'm sorry, on anxiety, exam, and revise, or how long a person studied. And to see the output of that, we're going to go back to RStudio and look at the console. In the console, we can see that anxiety, exam, and revise have appeared now. And we have a mean score for each one of these. We have standard deviation for each one of these. And you know about standard deviations. If your standard deviations are huge, you have a wide dispersion typically in that distribution of the data. If your standard deviations are small, there's, not that much dispersion in the data. You have your interquartile range here that we're going to talk about because we already did when we talked about the box plots. We will talk about skewness though, and the rule of thumb suggests that if you have variables that are larger than 1 in terms of skewness, then you might have a skewed variable. If this provided us with a skewness statistic and a standard error, we could actually divide that skew statistic by the standard error and standardize that score and decide how far away that score is from the mean and then make a decision. But you know that from introduction to statistics, so why are we spending time on it? And so we can actually make a decision now. We can say that skewness is an issue for anxiety, not necessarily for exam, and skewness is also an issue for revise or time that a person has studied. Kurtosis is not an issue with exam, but it is an issue with anxiety and revise. So the data is not necessarily normally distributed for exam, for anxiety and for revise, but it is for exam. And we can actually look at that again one more time through the graphs. And let's click up our commander and let's look at histograms for anxiety, exam, and I'm going to have to do these one by one. I could click on this and I could just, let's add some bins here. Yeah, we already have 50 there. And let's click on that and we can see that, yes, our data is skewed. We have these values over here that are skewing our data, are pulling it over to this end right here. So if we were to draw a line, this would be bunched up on the right hand side and it would be pulled out to the left hand side. Negatively skewed, again, from introduction to statistics. So that's it for using numbers to make a decision. The next video is going to look at some specific tests that have been created to look for normality.